Okay, so now we are going to do power notes. We just finished work, and power is directly related to work, so we're now going to take the notes on power. So let's start with the basic definition of what power is. Of course, my pencil's going to break. Okay, so power, let me turn off this so we don't get as much of a shadow. Okay, so power is the rate at which work is done so it probably works better with light, or the rate that energy transfers. Okay, so we know that we're using work and we're talking about a rate, and we also know that work is the same thing as energy in the sense of we use joules as its unit. So it kind of can be in two separate situations. We're going to talk mathematically about how it is a rate that work is done, but I'm also going to talk to you a little bit about what it means when we're talking energy transfer. So let's get right into the equation, because we know work has to be involved and we know it's a rate. And we talk about rate when we're being very specific with a certain variable in physics. And when we're talking rate, we like to use time. So in this case, we're going to have P, which is power, equals, and since we're using work, it's going to be work on top. And we're going to actually divide it this time by time because it's a rate. And we used rate before when we were talking about speed and velocity. So remember that it went a distance per amount of time, so it was a distance per time. In this case, it's going to be a work per time, work done per time. Okay, so let's talk about the units that go along with that. Work we already know is a joule, and time we know is a second. So we report this when we're saying it as joules per second. So we would say joules per second, but we like to give that a name as for power, which we call a watt. So I'm sure you've heard that before. So this is where it comes in as energy transfer. Go look at your power bill for your house, and you might notice that they're going to report it in kilowatts per hour. They're going to give us a rate that the energy is transferring to your home and being used, and therefore whatever those kilowatts are that you're using every hour, they're going to charge you money for it, and that's how we get our power bill. Okay, so a watt is reported out as a W when we're talking units. So we have a joules, a second, and a watt, which is power's unit. Okay, so there is a circle. And this time, since we're doing a division problem, work actually goes on top. Power and time are going to go on the bottom. So if we're looking for power, we can prove it here. We cover up P and we have W on top, and then we have T on bottom, so it's W divided by T, which shows us work divided by time here as well. Okay, so let's go right into the examples and solve for it. So the first example is going to be one of the basic ones using our basic equation. So how much power is used if 205 joules of work is done in 15 seconds? Okay, so we're going to do the same method that we always do. We're looking for power. How much power? We're going to underline what we're given and circle what we need. So we're given 205 joules of work, and we're given 15 seconds. So we will be searching for power. We're still going to need all three variables, a P, a W, and a T. So I'm going to write those down. Since we're looking for power, that's going to be an X watt. and work is 205, oops, not a zero, 205 joules, and my time is going to be 15 seconds. Okay, so I'm using the base equation, which is power equals work divided by time, since I'm looking for power. So I'm going to plug it in. Power is going to be X watts, or W, equals, now my W up here stands for work, so my work is 205 joules, and I'm going to divide that by my time, or T, which is 15 seconds. So there's no canceling here because remember, there's nothing you can really cancel because it is a joules per second. So a joules over a second, which is a joules per second. So we're just going to divide 205 by 15 and get 13.7 joules per second, which we call a watt. So 13.7 watts. Pretty easy. Okay, let's try another one. So number 2 is going to be a two-part question, so I'm going to give you a little hint there. So we're going to say that we have two 10-Newton boxes, okay, and they are lifted 12 meters up. Box A is lifted in 2 seconds, and box B is, oops, there's some space there, is lifted in 5 seconds. Which box uses more power? Okay, so this is a two-part question because we actually have two boxes to solve for. So we need to find the power for box A and the power for box B. So here's the thing though, we know that power is going to be a work divided by time. And if I look in here, we got to figure out what we're given, and we may have to do this in two parts, where we're solving for work first and then solving for power. So we have two 10-Newton boxes. So we know that newtons is representing a force, okay? And there's both boxes have the same force or force weight of 10 newtons. They're both going to be lifted up the same distance as well, which is going to be 12 meters. So we know that. The difference comes in when we're talking about the time. One box is done in 2 seconds while the other is in 5 seconds. So the time is where the power comes in. So due to the fact that we have no work solved yet, so nowhere in here do I see a joule, I can't solve for power yet. I have to solve for work first. So I'm going to do this as two parts, meaning box A, and I'm going to do box B. So I want to solve box A and box B separately. So I'm now going to have to think about what was the equation that I used to solve for work, because I have to have work to get power, and so far I only have force and distance. So my equation for work, just as a reminder from the last lesson you did, the equation for work is going to be work equals force times distance. So I know I'm given a force and a distance in this. So I'm going to start with my work, force, and distance variables before I get into power. So I'm going to be solving for work because I need to know what that is. So that's going to be X for me, and that's going to be joules, because remember work is in joules. I'm given a force for both boxes at 10 newtons. So I'm going to do this one alongside it because I'm solving for joules there. I'm giving them 10 newtons of distance. And I'm also, a force, and I'm also knowing that they're both 12 meters. So here's the deal. Both boxes are going to have the same amount of work. So technically, I don't have to write it all out both times. I have the same variables and the same numbers, so I could do the problem one time and say, okay, both boxes have the same amount of work done. So I'm going to just solve one of them and say, okay, work is force times distance. So X joules is W, I'll just write it here so we can remember. So X joules is W equals my force, which is 10 newtons. And I'm going to multiply that by my distance, which is 12 meters. Okay. And I probably can do that in my head, but if I can't, make sure you plug it in. And note that 10 times 12 is going to be 120 joules of work. So I have 120 joules of work. Each box is going to have 120 joules of work done. So now I have the first part of my equation done. So now the second part is the part that I'm going to do because I still need to know what power is. That's my ultimate goal. What is the power and how much, which box has or uses more power? Okay, so in this case now I'm going to move over to my power equation, which is going to be P equals work divided by time. So now I have a work and I'm given time in the problem. So I'm going to move it, I'm going to stay under box A, and I'm going to be listing my variables. And then I'm going to do the same for box B over here. Since I'm looking for power, it's going to be X watts for both of them. They did the same amount of work, so each one does 120 joules of work. And now the time. That's what's different. So I need to take out both times and put them for the right or the correct box. So box A is lifted in 2 seconds. So box A, 2 seconds. Box B is lifted in 5 seconds. Box B, 5 seconds. So remember, it is a rate. So power, my equation is going to be power equals work divided by time. So power is X watts. So I'm going to start with box A, and I'm going to solve box A so I know it's work, 120 joules. And I'm going to divide that by 2 seconds of time. And if I go ahead and plug that into a calculator, 120 divided by 2, or just know that 120 divided by 2 is 60 seconds. Or, I'm sorry, 60 watts, because it's a joules per second. Okay? Now let's find out what box B does. By now you're probably kind of guessing, oh, I have to divide so you can figure out which box is going to have more power, but let's get the number. So X watts over here, so we're going for power. Work is on top, so equals 120 joules divided by 5 seconds. So 120 divided by 5 is going to give me 24 watts. Which box uses more power? And that's going to be box A. Uses more power. Okay, so we're going to do one more together. Okay, and that's going to be number 3. Oh, get my camera to work out here. Okay, so number 3. I had to switch pages. So a 75 Newton goat. So remember, that's its weight, its force weight. Goat climbs a hill that is 50 meters in 16 seconds. Fast goat. What is the amount of work done by the goat and how much power? Okay, so again, it's a 2-part question. We got to do both of them. So I'm almost out of time on this one. So I'm going to close down this video and then start part 2, since this technology only gives teachers 15 minutes per video. So I will make the next one and finish that after. Okay.